Bionics explores the interplay between biology and design. As you can see, my legs are bionic. Today I will tell human stories of bionic integration, how electromechanics attached to the body and implanted inside the body are beginning to bridge the gap between disability and ability, between human limitation and human potential. Bionics entails the engineering of extreme interfaces. There's three extreme interfaces in my bionic limbs: mechanical, how my limbs are attached to my biological body; dynamic, how they move like flesh and bone; and electrical, how they communicate with my nervous system. I'll begin with mechanical interface. In the area of design, we still do not understand how to attach devices to the body mechanically. My bionic limbs are attached to my biological body via synthetic skins with stiffness variations that mirror my underlying tissue biomechanics. To achieve that mirroring, we first developed a mathematical model of my biological limb. To that end, we use imaging tools such as MRI to look inside my body to figure out the geometries and locations of various tissues. We also took robotic tools. Here's a 14 actuator circle that goes around the biological limb. The actuators come in, find the surface of the limb, measure its unloaded shape, and then they push on the tissues to measure tissue compliances at each anatomical point. We combine these imaging and robotic data to build a mathematical description of my biological limb, shown on the left. You see a bunch of points or nodes. At each node, there's a color that represents tissue compliance. We then do a mathematical transformation to the design of the synthetic skin, shown on the right. And we've discovered optimality is where the body is stiff, the synthetic skin should be soft. Where the body is soft, the synthetic skin is stiff. And this mirroring occurs across all tissue compliances. With this framework, we produce bionic limbs that are the most comfortable limbs I've ever worn. Next, dynamic interface. How do my bionic limbs move like flesh and bone? At my MIT lab, we've studied how humans with normal physiologies stand, walk, and run. What are the muscles doing, and how are they controlled by the spinal cord? This basic science motivates what we build. We're building bionic ankles, knees, and hips. We're building body parts from the ground up. Moving on to electrical interface. How do my bionic limbs communicate with my nervous system? Across my residual limb are electrodes that measure the electrical pulse of my muscles. That's communicated to the bionic limb. So when I think about moving my phantom limb, the robot tracks those movement desires.